we will solve this today's weekly contest 400 problem. So this one is the third problem. So here it is given lexicographically minimum string after removing stars. So let's see what the problem is asking. So it's given that we have given a string as, and it may contain any number of star characters. Your task is to remove all star characters. Okay, so while there is a star, do the following operation: delete the leftmost star and the smallest non-star character to its left. If there are several smallest characters, you can delete any of them. Okay, so we have finally we have to delete the leftmost star which is present, and to its left the smallest leftmost star character, left part, the smallest non character to its left. We need to delete both of them simultaneously, right? And that's how we need to return the lexicographically smallest string after removing all star characters, right? Okay, so the two things here, that we need to remove a star, we need to remove a star with from left, and also non-star characters, non-star characters from left of star. And which characters? The smallest character present from left of star, right? Okay, so and second thing, that we need to also make the string lexicographically smallest possible lexicographically let's lexicographically smallest, right? We just need to make it lexicographically smallest string after removing uh, all the stars and the minimum characters, right? So in this if you see that we need to maintain, if you see, we need to maintain the smallest character. So we will definitely iterate from, we will definitely iterate from definitely iterate from left part, right? We will definitely iterate from left part. So if we see a b a star, if we see example a b b star, we will iterate from this a part, this a part, right? We then go a part, b, a, then star. Whenever we got a star, it means I need to remove this for sure, but I need to also remove the smallest character which is in the left of this star. So in this left of the star, this a is the smallest, a is the smallest, right? A is the smallest. So, but which a should be removed? So if you see here, we need to remove the lexicographically smallest, right? If you want to find lexicographically smallest, it means we will remove that a which is at rightmost position, which is at rightmost position. Because if you remove from the leftmost position, it will not generate lexicographically smallest string, right? Because suppose you have removed this a from for this, so it will be aba. If you remove from this second, this will again be aba. But if you remove from the last, this will gives aab, right? So which is the lexicographically smallest? Of course this one, of course this one, right? So we will remove that smallest character which is at most, which is at rightmost position, right? On the on current state, on that current state, on that current stage, right? On that current stage. Okay, so if you observe here, we need to do two three things. First, we will iterate from left to right, right, to find the star, of course, right? Because we need to delete the leftmost star present, so we will iterate from left to right for finding the star in string, right? Also what I need to do, I need to maintain, I need to keep track of the smallest character present to its left of a star. Means while iterating from left to right, while iterating from left to right, i need to I need to keep track of smallest string present till that start till that start position till that start position, right? I need to keep track of that, because if we want to remove this star, I need to also remove that character present, right? Also 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 there can be many smallest character present. There may be many, there may be multiple smallest character present left of in left of start in left of left start, right? Start position, right? So which character we need to remove? We will need to remove the we will remove we will remove the rightmost smallest character, rightmost smallest character, right? If there are multiple smallest character present, then we will remove the rightmost smallest character. Then we will get only lexicographically smallest string, right? Smallest string. Okay. Okay, so this we can do that. We will iterate from left to right. But how will we maintain a track of a smallest string till this position? Also, there can be multiple small character. So how we will maintain this? So if you know, if you think of any data structure, if you think any of data structure which gives you the smallest element. One is, I can think of heap. Do Can you think of in heap what mean heap? What does mean heap do? It gives us it gives us the it gives us the smallest element present. It gives us the smallest element present in heap in total values, right? So its top value will be the smallest. Its top value will be the smallest, right? Its top value always give the smallest. So how we will use heap? So one thing is here clear, that I need to remove the smallest character, which I can use heap. Second thing, I need to also see to remove the rightmost character. So I need to maintain index also. I need to I need to see the character index also. So what we will store? We will store pair. We will store pair of character and index in mean heap, right? Right, we will store character and int in mean heap, right? Simply. So when we store pair and int when we store char and int in mean heap, so when we get start, then I am sure that the top element the top element will give me the smallest will give me the smallest character, right? Also, simply I will make a comparator function. I will make a comparator function separately to know that this int would be the larger value, this character would be the smallest, and this int will be the larger value. What does it mean? So if you see here, a is present at 0, 1 and 3. A was present at 0, 1 and 3, and b is present at 2. So between this A and B, A is the smallest. But in this A, which character need to choose in rightmost, the top, the greater index, which is 3. So we will make a comparator function. Comparator function. Custom. We will use a custom comparator to short it like that, right? To compare it like that, and we will remove this a and 3 from this string, right? Also, after iteration, after completing iteration, if you see here, this order is maintaining, this AAB is order maintained. So after completing iteration, how will I return the string? How will I return the string? So for that, what I will do, I will take a help of another. I will take a help of another what? Another vector, another vector of another array of int of arrays to store all the indices which is left in heap, right? And sort it simply, and I will sort that, and I will sort the array. Why? Because after using all the min heap characters and going through all these characters, the characters which are left on this heap will be sure that these characters are will make a string, and that will be returned, right? So but the order should be maintained, and how will form the order? We will simply, we have already stored our indices in heap, min heap, so I will store all the indices in vector, in array, and I will sort it, and I will simply go through each elements of new array, which is this new array, and store all the characters and return it simply, right? What does it mean? See this, suppose I take example a b a c star, let's take a star here, c b a d star, or take as a star here d f, right? So what I'm telling, I will iterate in this. So when and also maintaining in my heap priority queue, that I with my with what, with indices. So first thing is a, so a will be here and 0 will be here indices. Second is b, sorry, and this b will be here, this a will be here again, so a will again store with 2, right? Now if you see here, this star, when this star came, this star is should be removed, but with a star to its left, this ABA should be removed, one of the smallest character with the rightmost present, right? So if you see which is the small, mean he will give the top element, the smallest character. So top smallest character is A, but in this A there are two A present. So we will see the indices which is at 2, we will, which is 2, so we will remove this a2 because that will be the top element, so we will simply remove this, and this is left, right? So this is start gone, this is start gone. Now c is here, so we will insert c, this is present as 0 1 2 3 4, it is present as 4, right? Now this start is again, so we will remove this start left's value, so left smallest is a, so a0 will be removed here from here, right? Now this d is left at here, it is at index 6. Now again f, this is at index 7. Now this is the left 0 1 2 3 4 5 6 7, right? So this is left in my priority queue, but I cannot directly pop out this and make our new answer string. Why? Because this will give, always gives me the smallest string present in this and indices. So this will not. If you see in this example, this will give me in order, but but in most of the cases, it will not give me the string in order wise, right? So I will do, I will take a help of another array, and I will store all the indices of this here 1 4 6 7, and sort it, which will be same as 1 4 6 7. I will sort this after sorting, after after sorting, after sorting. I will simply sort it. I will simply sort it. How do I make this? This and this, right? I just, yeah, this. after sorting, right? Just give some space. Okay, so no problem. I think you understood this. What I'm trying to make, and I'm making type downward array, right? So after sorting, this become this. Now what I will do, I will create in this array and simply is store all answers in my answer vector, which is one as the present, a, which is a. Then 4 0 1 2 3 4 0 1 2 3 4, which is C. Again 6, which is D, which is D, and 7, which is F. So this would be my answer ultimately, right? So this is how we will do this. Let's implement this. You will better understand. Or I should show my code simply to you, right? Or just okay. Let's try to implement this in front of you. You will better understand. So first thing is, I will take a min heap. For that, I will use a priority queue, and I will store a pair. So for that, I will just make a micro for that, type def, and this will be pair char int, and I will just define this as PCA or something. You can definitely define it as any with any name, right? So what I will do, I will simply write this vector pp and a comparator function. So what this comparator will do, it will sort it according to my, this is the custom comparator function. So I need to make this comparator. So what I will do, I will make a comparator function. So I will make a class compare this should be compare. Just take it as a compare. Okay, and in this, what I will do, I will simply see that which is I need to make a function which will be made a public to use that operator. So I will just use this as my uh, function to compare for comparison. So this will be the check. Let's make it as a check, and this will give us simply the what I will pass here. I will pass here by the this pi will which I have made. So let's just not define here. Let's define it here. So just make it as has defined uh, pair char intent, and this should be here pp. So if you write like type def, you need to define macros. You need to write like this and pp. But if you use define, you need to first define a macro, and then you can define the what we need to define, right? Simply. So this is how we will define. So we will just pass this pa, and this just pass as bb. Now, now the thing is that what I need to see, I need to maintain in the short string. So the first character would be the smallest one. The first character would be the smallest one. So what I will do, so the first part should be in the smallest one. So if this is correct, then it is good. Then I will return it true, right? I will return one. Otherwise, if both is equal, what I need to do, I need to take the, if both are equal, I need to take check that if a dot second should be less than a dot second should be less than b dot second. Why? Because I need to check the rightmost part. So I will just return one. Otherwise, I will return zero. If any of the case failed, I will return zero. So this is the custom comparator function we use here. So this thing will sort the first part, the character part, in ascending order. And after this, if both of the character is same, it will sort it in descending order. That if the getter int will be there, then it will generate in descending, right? Simply. So this is This is the comparator function we use here in this comparison. And now what I will do, I will just iterate in this string. And now if the si is start, if si is a start, it means I know don't need this start, and also I need to remove the top element which is present at priority queue. So I will just pop that out. Otherwise I will insert what, I will insert this character with indices, simply, right? After this some elements will be left at the priority queue. So for that I will take an extra array and store all the indices left over in this priority queue. So I will just move in this priority queue and store this indices, right? It's just an implementation part. This pq.top will give me the first, the pair, and the second will give me the indices, right? This will give me indices, and we will pop out, and then again and again till pq is not empty. And now my array has all the indices, so I will just simply short it, right? I will just simply short it. Now I will iterate in this array. I will iterate in this array and take an answer string to return an answer, and I will just push back this as of it. What this it will give, this it is indices, and this sit will give me the character which is present at this index in string, and that is the answer, and I will just simply return that answer, right? So this is how we will run this. Let's try to run this. I hope I have not make any mistake here. I have made a mistake. Let's check that. uh, Function bool character, bool pair current should be not checked. mm, okay, I have made a comparison function, and I have made, okay, this should be operator. This should be operator. Why? Because this is a custom function, and it is defined like this only. It is defined like this only. If you want to see, I will give you some reference. It is defined like this operator function, and now this will work fine. Yeah, let's submit it. We have successfully passed the sample case, all the test cases. So what the time and the space complexity? Although this may be not an optimal solution, because I have taken a priority queue, then I'm taking an extra array for sorting it, then I'm using that to store in answer. That would be definitely not a optimal solution. There are many solutions which can be efficient like this, but I have solved it like that during contest, of course. So let's just uh, analyze this time and the space complexity. So I am inserting all the characters, all the non start characters in my priority queue. So that would be take o of n log n, because every insertion takes log of n. So n log n for that. Again, I am inserting array in this, so that will again take o of n log n, because after that I am sorting it. And yeah, for it iteration again o of n. So that will be overall o of n log n approach. And the space complexity is, so I am taking o of n, o priority queue, so that will be o of n, right? Again I am taking array, that will again can be o of n. So overall of o of n, right? Space and the time complexity will be o of n log n and o of n. So this is how we solve the questions. For this I will give you a reference for comparator functions. I will attach a link in description, you can see that. So hope you understand the question. So thank you so much.